Thanks, everyone. I won't. I'm probably just going to talk and not show anything, so you can just listen to my voice. Um, yeah, as you know, 120 is still on its way, hasn't come yet, and it's been quite a while since 119.1, which was 888 commits ago, I think. As in, that's how many commits it was since then. That was so it's definitely been time for a release. It's just releases always take a long time. There's a lot of things to do, and this time the headline, I guess, for this release is Pico W support, because we still haven't had a proper release with Pico W. So sometimes people are getting confused now with the only downloadable firmware for Pico W is the unstable one. And there are a few things we wanted to tie up and clean up with the Pico W release, because it's the first time that's board's been released. So there are some networky things still left in the queue. There's one thing left from Jim to tidy up how you set host name and fix up a few things there so it works. And I guess a lot of things we do these days are really trying to unify ports and behavior and clean things up. Jim also has a really big set of documentation changes coming for that, in that sort of vein. And the other thing we're waiting for Pico W. So Pico W has Wi-Fi and Bluetooth, and Bluetooth support is not there yet. It's very close. It's partially there. It's in Pico SDK and the ZYW43 driver. So that hopefully will also be part of the release if that comes out in the next couple of weeks. So that's sort of what's been holding it up lately. But yeah, so in 888 commits, there's been a lot of things, and I'll just go through, I guess, the highlights of that. So this is essentially like a pre-release note discussion of what's going to come out in 1.20. So as I said, Pico W support is sort of one of the main, the headline thing, with Wi-Fi and hopefully Bluetooth as well. There are a few interesting Python features that were added. We now have support, for hex and from hex methods on bytes objects, and also byte array and memory view. So there is been ASCII.hexlify and unhexlify, but bytes hex and from hex are sort of those counterparts, which are acting on objects. Seems a bit more Pythonic, you could argue, or you could also argue it's unPythonic because now there are two ways to do something. But there's a little bit more power in using hex and from hex, because you can. The result you get, I think, is a bytes versus a string from hexlify, and it makes a little bit more sense. Anyway, we added that feature. Added support for dunder float and dunder complex functions, and dunder dict on modules. Sys.executable on Unix will give you the Unix executable. And then there was dictionary union, which was PEP 584, was implemented as well. The other thing was that strings are now validated for their UTF-8 correctness. Previously, if you could construct a string which is supposed to be a UTF-8 string from something that was invalid UTF-8, and then that could lead to like seg faults and undefined behavior. But now, whenever there is a string being created from an untrusted source, like a file, for example, it's verified that it's UTF-8. But if it comes from a trusted source, like if you're slicing an existing UTF-8 string, you don't have to check again that it's UTF-8, because you know you're slicing it correctly. So there's some Python features that were added. There There might be some more that I've missed, but they were the main ones that I found. The other main thing was the introduction of the MIP package manager, and more heavily relying on MicroPython lib. So MicroPython lib has become a submodule of the MicroPython repository, and we've moved a lot of drivers and other things into MicroPython lib to make more use of that, essentially. And so now you can freeze in arbitrary code from MicroPython lib into a firmware. And MIP is the package manager which allows you to retrieve things from MicroPython lib outside of a build. So if you're running on the board over network or using MP remote MIP to install from your PC. So we hope to move more in that direction of using MIP as a package manager, MicroPython lib, to hold all packages and also references to third-party packages in the future as a more of a curated list, as in, well, more curated than PyPy, so that if something comes from MicroPython lib, you can trust or hope that it runs and works. That's the idea. And yeah, we're discussing with Matt the other day, ideally in the end, we want to be able to do, MIP install some random driver for something like a temperature sensor or display or humidity or something like this, and then it just pulls in everything you need. So maybe it's an Adafruit library for CircuitPython, and it pulls in all of the required CircuitPython intermediate layers to make it CircuitPython drivers work on MicroPython, like their sort of I2C and bus IO things. So if there's a driver that's only written for CircuitPython, you could still hopefully install that on a MicroPython based system and use it. So that's the sort of thing we're thinking of in the future, so that you have access to all the drivers out there, and having them work. And well, with tests would be good, but yeah, that's sort of the more longer term path there. So we've started to move in that direction in this next release. So that's that. There's been sort of a lot of fixes. So I don't know if you're aware, but sometimes when you use floating point numbers, they print incorrectly, and maybe parse incorrectly. So, if you have the number 123.0, sometimes it'll print as 123.00001, depending on whether you're using single or double precision or what hardware you're on. And people sometimes complain that that's incorrect, where internally it's probably stored correctly. It's just the printing of the number that MicroPython doesn't handle perfectly. And some of those cases have now been fixed. So there was quite a bit of effort there to improve parsing of numbers, like with trailing zeros, and to support printing or formatting of floating point numbers that are exact integers. It also helped fix other cases as well. Getting it perfect is really hard. I mean, it's not like we could do it, but it just takes a lot of code, and that's not really worth it, I don't think, to have a huge amount of extra code just to make printing of floats exact. Internally, they're still stored correctly and all the operations are correct, but we do now print and parse floats a bit better than before. Also, parsing of complex numbers was fixed up. You can write NAND J and infinity J, and that actually works now, whereas before it didn't. So that's a bit of a user-facing change. Another thing you might notice we've tried to unify embed TLS, so RP2, STM32, MIMXRT, ESP32 as well. They all use embed TLS for the SSL module. And we've tried to unify the configuration of those so that if you can connect to a website on one port, you should be able to connect to a website on another, as in they all have the same features enabled. And elliptic curves were enabled there because they're very popular now in websites. Some websites only support elliptic curve cryptography. And even though it's expensive to enable such a feature in terms of code size, most of the ports that have Wi-Fi or networking have enough flash that it's okay to enable that feature. And, you know, if you've got a network connected board, you want to be able to connect to an internet site which has cryptography. So we need to enable these things. There's not really any way around this. But yeah, it's fine. My point here is that we're trying to unify and make it so that we are able to support most of the sites out there and the same on all ports. So that's something you might notice. Eventually, after this release, we're going to try and improve the SSL module to move to SSL context class, and then that will allow us to do SSL in async IO, which is still not complete. So that's that. The one thing you probably won't notice, but it's interesting, is the MPY files now have a subversion, which is only used if you have native code in it. So MPY files are at version 6 at the moment, and they have been for a while, and that's not going to change in this release. But we did introduce a subversion so we could change some native code things, format of certain native code objects without changing the bytecode, so that bytecode from previous version 6 will still run, but native code from, say, version 6.0 won't work with 6.1 and vice versa. So that's something that you may notice if you have native code. The other thing, maybe if you're working with the Unix or Windows ports, so in this release, this happened a while ago, but it's still not part of a release. The executables have moved to the build directory. So it used to be in the Unix port when you built it, the MicroPython executable was just in the ports/Unix directory, but now it's moved to ports/Unix/build. Same with Windows and MPY cross. And that makes it more consistent across everything, that build artifacts are always put in a build directory. And if you delete the build directory, you delete all artifacts, and that's how it works. So that cleaned up a few things, which was nice. Getting more into the internals, if you're developing with MicroPython, you'll notice in the next release that the type system has changed, the way you define types in C, like any Python type, like string, dict, list, or anything. So we made this change. Jim did a lot of work, most of the work on that, based on inspiration from CircuitPython, to compress the type information, because there are many types in Python and in MicroPython. I don't know, it's 50 or something, or even more if your port defines lots of types. These types take up a lot of space because they were originally 13 words, and 13 words times 50, 60, 70, 80 types is a lot of code size, and a lot of the entries in those types were never used. So what has happened there is the types have become a compressed data structure. So instead of having 13 slots and just indexing, whichever slot you need, whether it be for a binary operation or an iterator or something, the slots are now compressed. You only have as many as you need. If you only implement 3 of the slots, you only need room for 3, plus a little table at the beginning which indexes which slots you have. So you pay overhead for the table, but you only need to then use as many slots as that you actually have filled. And so overall, that makes quite a big saving. That's you'll only notice that if you're developing for MicroPython in C, but it's important to know because you'll definitely have to change your code there. So that's one of the other internal things. Along with that, there were also a way to register root pointers now with a macro, so you don't have to accumulate all your root pointers in one big hash define each module that you create. At the bottom can do MP register root pointer and just give a pointer as many as at times as it likes to add root pointers to the root pointer set. And that goes alongside your MP register module for user C modules as well. So it's a lot cleaner now to define a user module that you just do MP register module and MP register root pointer at the bottom, and that automatically gets picked up when you build that module into your firmware. So that was a nice improvement there. Jim also did that. He's done a lot of work in this release. We also have now the ability to have a split garbage collected heap. So before, the GC heap was just one contiguous chunk of memory, but now there's an option that you can turn on so that you can have a linked list of memory pools which create the heap. So you can have one or more, and they can be added at runtime as well. They don't have to be set up at the beginning. So we don't, I don't think we actually use this in any of the ports yet, but we will use this to improve ESP32 heap fragmentation. And it can also be used in cases like, say, on STM32, if you have external SD RAM, you could have some of the heap in internal RAM, and then a small chunk of the external SD RAM could be added to the heap later on if you wanted to. We could make it dynamically size it so that as your program's running, if it runs out of heap memory, you could add a chunk from the external SD RAM and do that over and over. We could also do that with the Unix port so that you don't have to set upfront the amount of heap you want. You could just make it automatically increase if you needed more. The reason not to do that is because a bigger heap can slow your program down because it has more that it has to scan when it has to do a sweep. But so there's always a trade-off there. But at least this gives us a good tool to try and improve the situation on things like ESP32, where the heap is quite fragmented and you've got external RAM usually as well. So the hope is with that we can just enable SD RAM, PS RAM on all ESP32 builds. It can automatically detect if it's there. If it's not there, it just doesn't use it. And if it is there, only add the PS RAM to the heap if the user either requests it explicitly or automatically, if we want to do that. So that should allow for more flexibility, that one firmware can be used with and without PSRAM, and should solve the problem with fragmentation of the IDF heap on ESP32. So yeah, that will be the next step, but at least the split heap is there to start with. So yeah, that's that feature. This is something, well, you won't notice this, I guess, but it's sort of behind the scenes optimization. There are more, you will notice this sometimes, but the parser can now handle more constant types. So if you in your code have a tuple of integers, that's a constant because tuples are immutable and integers are immutable. So a tuple of integers is a fully constant object, and the compiler and the parser together will now make that actually a true constant in the code. So it's definitely recommended when you're writing code, if you can choose between a list and a tuple, choose a tuple if it's got all constant elements. This won't work if it's not constant, like if it's got a variable x, or it has a byte array that's not constant. But things that are constant are obviously tuples, integers, floats, strings, bytes, objects. So any of those, and also booleans, any of those things and any combination of those things is now a pure constant, and that optimizes the memory use and the bytecode. You don't have to construct it when you run the code, because before this optimization, if if you had a tuple of integers in your code, then when the code ran, it would have to construct that tuple of integers when it arrived at the statement where you wanted to use it. But now, when you arrive at that statement to use this tuple of integers, it just loads the constant with one instruction, with one opcode, and uses it immediately. And it will reuse that one the next time it's run. So that's a big, that's a nice improvement. And especially with precompiled bytecode and MPY files, these constants are stored in the MPY file as a constant and loaded as a constant. And you can also use these, we use tuples now in const expressions, as in from MicroPython import const in that kind of expression. So that can help a bit with improving efficiency and code size of bytecode. So that there obviously that's not everything, because there's a lot of 888 commits. I did not describe all of them, but some other things. There's been Robert, a lot of work by yourself with the SAMD port, MIMX RT as well. They've come a long way since their beginning. They all now support named pins, I think. So SAMD, MIMXRT, RP2, and STM32, they all support named pins now.
Is SAMD new in 120, Damien? I think it was.
The whole port?
Yeah.
No. SAMD's been there for a while.
Well, sorry, it was since. Okay, cool.
It's been slowly improving.
Yeah.
Okay.
But yeah, named pins is now becoming more common than rare in ports, which is great. Yeah, so that's another nice addition. And yeah, there's been a whole lot of other stuff, lots of bug fixes, and yeah, improvements of CI. CI is always ongoing. There's always problems with CI, continuous integration, and it always needs fixing, but always ongoing stuff there, always ongoing docs, and just general improvements to the system to how everything works. So that's good. Yeah, I'm just looking at the SAMD list. It's very long. There's a lot of stuff that was added in this release.
Yeah, I'm pretty sure it was just like the minimal port at 119. But, maybe I'm wrong.
No, but it had file system in the previous release.
Okay, yeah. And so it had files and pins and not a lot else.
But yeah, a lot has changed in this release for that. PWM, SPI, UART, really good. Thank you, Robert. That's definitely much appreciated. Also, the JavaScript port was renamed to WebAssembly, and a few things fixed up there. There's PyScript, which is maybe going to play a bit of a role improving that port in the future. So I think that's all I wanted to say, except, well, just at the end to say that there have been a lot of people contributing to this release. Pull requests, obviously, that's how people contribute. I think there's around 80 or 90 unique contributors. So in 900 commits, that's, well, yeah, that's a good percentage of people contributing. And we now try and list in the commits themselves the sponsorship of what, as in how the work for that commit was funded, usually through GitHub sponsors, which has been really good as well. So the release notes will list the contributors and also the funders of the work, and that's what I'm in the middle of writing at the moment. So that's about all I had to say. As I said at the start, we're sort of waiting. There's one more network thing to merge, and then hopefully PicoW Bluetooth support would be a great addition, and then it will be released. hopefully by the end of this month, which is not long away. So yes, stay tuned for that, and then we get on to the next release or the next set of work. There's a whole lot of pull requests that just sort of lined up to merge after the release. Some embed TLS things and SSL things and lots of other stuff. So yeah, it's really good. Thanks for listening.